Okay, hi guys. My name is Maciej Aniserowicz. I came from Białystok in Poland. I'm a developer, an architect. I blog a lot. I have my own podcast, but it's in Polish, so it probably won't interest you that much. I'm also a trainer. I do workshops about testing, solid patterns, and about microservices. And when I was going to various clients, big and small companies in Poland, I was able to see how they struggle with microservices, what problems they have, and how we can solve them. And the talk is micro facts and micro myths about microservices, because we see a lot about microservices in the last 2 or 3 years. And you might think, isn't it too late? Why this subject again? And to be honest, I am myself a little tired with microservices because it became so popular and so trendy that everybody is trying to talk about it, everybody is trying to write about it. But I have this observation that many people who do this don't really have experience in microservices. I attended CraftConf conference last year in Budapest. I know any of you have been there. There was, I guess, 150 talks, and I had this impression that about 100 of them was about microservices. And the things that I heard there, well, just I couldn't believe some of them. And to be honest, I was doing microservices even before it was called microservices, because I was doing for like 5 or 6 years now. And from my experience, I will try to show you some of the sentences that you can find online about microservices, and we will wonder whether they are true or false. But first, the obligatory definition. So microservices, in its simplest form, is just a set of small applications of separate processes that are forming some big business component. And often, microservices evolve from one single big application, which we call a monolith. So when we have one big application, we can split this application into smaller ones, and then we have microservices. And another perspective is, from my observations, the more true one. Microservices, by definition, is the process of splitting big ball of mud into small pieces of crap. And unfortunately, this is often true. And our job as developers is not to go this way, but to consciously consider all the benefits and all the disadvantages of microservices and make the decision whether they are fit for our system or not. So we must not allow this to happen. So the first thing that we can think about microservices is that this concept is something new, because everybody is talking about this. Well, it must be something in it, so that it must be a revolutionary concept. So is it true or not? Well, when we look back at the history, we can see that in 2003, 13 years ago, Eric Evans published a book called Domain-Driven Design, Tackling Complexity in the Heart of Software. And domain-driven design says that we can take our system and split it logically into smaller subsystems, into smaller components called bounded context. If we have one big e-commerce application, we can split a component that will take care of sending our orders. Another component will take care of users' registration. Another component can take care of security, and so on. These are all bounded context, and we can split our code logically to handle these tasks. Another book published 11 years ago, in 2005, is called Service-Oriented Architecture. Service, not microservice. Service-oriented architecture can help us take what we learned from DDD, how to split our application logically, and split it into separate processes. So how to split our code physically. And these two concepts are quite old. And in my opinion, microservices is SOA done right. It doesn't necessarily have to be micro to be good. We will get back to it later. And we might wonder why now, why microservices are so popular now if these concepts were present already 11, 13 years ago. And in my opinion, we as an industry, as IT, just weren't ready for it back then. Because when we heard SOA in 2005 or 2006, we immediately thought about banking, about enterprise, about XML, about SOAP. And it was very heavy, difficult, hard, and basically it was no fun. But now we have cloud, we can automate things, we can set up our environments very easily, very cheap. We don't need hardware, we have tools for that. So in my opinion, this is why microservices are so popular now. So microservices isn't anything new. It's just the same concept that we have had in our industry years ago, but now we are ready for it. We have the tooling, we have the knowledge. Now we can fully benefit from these two books. Another thing, if everybody is trying to do microservices, they must be fun, right? Anybody recognizes what game it is? Heroes of Might and Magic 3, the best game ever. My friend Andrzej tweeted this once. He took a screenshot of Master Chef for kids when the kids are going to the kitchen and taking various stuff to cook meals, and they are very happy. And he commented that this is how developers look like when they work on a greenfield project and they can choose any framework they like. Well, it's true, but let's face it, most of us, I don't know about you, but most of my friends in IT, we don't work like this. We work in the old, ugly code written in .NET 1.1 or some old Java written 10 years ago. Somebody has to maintain it. And this situation happens not so often. But if we do microservices, if we approach this problem appropriately, then we can say that one microservice can be written in .NET, another microservice can be written in Ruby, another microservice can be written in, I saw some Java talks here, so in Java. Another microservice can be written in Node, and this can be even treated as a reward for a team of developers that does the best job. What if a manager comes to your team and says, if you do the next sprint really well, for the next month or two, you can play with stuff, you can play with tools, you can experiment, you can learn, and push the effect of your learning to production. It would be awesome. And to be honest, I'm in IT for 11 years now, and I got a little bored with coding because I was doing the same thing over and over again. If I could just take any tool I'd like, apply it in my system, push it to production, and watch how it works or how it fails, it would be awesome. What it means is that let's wonder what is the most important decision in most of the projects. Well, it's not about business. The most important decision in most of the projects is what technology will we use. But does the client really care what technology is the system written in? Well, no. Any system written in any language can earn money. If we approach this problem this way, the decision about the technology becomes irrelevant because we can always write the same thing in the tool that we already know if the new tool fails. And it is a great opportunity to just learn all the time as developers, not after hours, not in the night, but during our daily job. So we had development experiments, but what if we tell our business that they can come with any crazy idea they'd like? We can then deploy it to production, and if it doesn't work like they expected, we will just undeploy it. We will revert this change, and we will deploy the old version without any problem in a matter of seconds. If we have one big application, the deployment process can take hours, can even take days. But if we have a set of small applications, then the deployment process takes seconds, and it is often a matter of a single button push. And we have the version that we'd like on production in a matter of seconds, if we do microservices right. So now we have business experiments. Do whatever you like, and it won't be harmful ever, because we can always go back to the old version. What is also beneficial is that splitting the tasks between developers, between the teams, becomes really easy. Nobody is stepping on each other's toes. We don't have merge conflicts, because we all know that in Subversion or on Git, these are great tools because the branching works. But the sad truth is that the merging is the problem, not the branching. if we do microservices, then every microservice is in its own repository. Every team has 1, 2, 3, 5 microservices under its care. And just we don't have much conflicts because we don't need branches, basically. And every team's work is fully autonomic. They can make their own decisions. They can choose their technology. They can choose their deployment process. Only the final effect matters, not how they do it. So are microservices fun? Well, yes, they are. I've been doing microservices for years, and it is really fun. It can change how developers work and how developers think about their job and how developers evolve to be better developers. Another thing, if microservices is nothing new, but everybody is trying to do this now, and if they are so fun, are they simple? Well, let's see. Martin Fowler, a great authority in microservices, said once that you must be this tall to do microservices. And what he meant by that? I saw many times when I went to consulting in some companies that they just thought microservices, yes, they are great. They were sold out to the whole microservices marketing. We will do them now without any preparations. And the truth is that if you do microservices without any consideration, without any preparations, if your organization isn't ready for it, you will fail. There is no way that you can do microservices without continuous integration, without continuous deployments, without automated testing, without all this stuff, without automation scripts. Because you know this song from Metallica, The Shortest Straw. And the process of deployments in many companies looks like this. A whole bunch of developers is sitting at the table. One of them is holding a set of straws, some sticks, and whoever picks the shortest one stays at night and tries to deploy this damn thing. And it never works. So I guess Metallica might do something with deployments. What is also important is that it also applies to databases. Continuous integration and continuous delivery, continuous deployments with code, with applications, isn't really that hard. The hard part are databases. And the important thing is to treat database as code so that we can also automate the whole process of database deployment so that we don't have to do basically anything manually. We have tools for that. I'm from the .NET world, and in .NET we have TFS, but let's not talk about it. Let's say that we have TeamCity, which is a great continuous integration server that automatically compiles our application, automatically tests our application. What then? Then we need some way to manage dependencies between projects and to package our applications for deployment. We have NuGet for that. In other technologies, there will be other package managers. And I don't know about other technologies, but in .NET we have this tool called Octopus Deploy. And it's a wonderful tool designed to deploy applications. It takes applications packaged as NuGet packages and just installs them in a very straightforward way into various environments that we set up. And to be honest, if you do .NET and you don't know Octopus Deploy, please install it, play with it, because I don't imagine working as a .NET developer now when I know how Octopus Deploy works. We can also configure TeamCity or Jenkins or Bamboo to do this thing, but Octopus Deploy is just the best. And the important thing is also to not forget about money, because cloud can be cheap, but cloud can also be expensive if we do this without considering the real costs. And I went this way, and I don't recommend it because people shout at you then. So microservices are not simple as the overall process. Microservices make the development part simpler and more fun, but the real problems appear after you do git push. So you need to have DevOps culture in your company. You have to be prepared to automate things, to invest time in configuring all these tools. It's not that hard, so that everything can be done automatically. And in our company, it was a great relief when we installed and configured all these tools so that deployments were done automatically, because our responsibility as developers was finished after we did git push. Then TeamCity took our code, compiled it, ran tests, and so on, produced nuggets. Then Octopus Deploy automatically installed each commit on a test environment and sent email to our client, hey, new test version is available. Please test it. And if you are ready, if you think that it is good enough, go to Octopus and click deploy to production. And it was the customer's decision to do this. If something didn't work, well, it wasn't really our fault. It meant that the customer didn't test it well enough. And it was a great relief, and it let us, well, enjoy our job more. There are many discussions how micro should a microservice be. And I heard a lot of opinions on that matter. I attended one conference where Chad Fowler from the tool called Wunderlist was presenting, and he said that in Wunderlist, every single method, not class, not component, every single method is deployed as a separate microservice. For me, it seems too extreme. I wouldn't go that far, but it works for them so great. So this is one approach. Do it as micro as possible. Another recommendation that I heard, and it's the most, I'd say, stupid one, is that microservice should be at most 400 lines of code. And I wonder who is counting how much code we have in lines of code in the 21st century. Well, you can't do this really well. So let's forget about it. Another approach is to apply DDD, domain-driven design. Every divided bounded context that we talked about earlier can be deployed as a service or as a microservice. So it is a great way to do microservices if you already know DDD and you know how to divide your system into bounded context. Well, but it requires some prior knowledge. And the best recommendation that I heard is from Greg Young, who will be talking later today. He said that microservice should be microservice size should allow it to be rewritten in a matter of a single week. And I love this recommendation because it doesn't tell you how many lines of code, because it will differ from technology to technology, from system to system, and from team to team. So the true answer to this, how micro should the microservices be, is, well, it depends. It depends on the skills of your team. It depends on your experience. It depends on the tools that you use. And it depends on how well you understand the domain that you are trying to implement. When we think about microservices, we can wonder how independent they should be. If we really should divide our code and our deployments as much as possible. Well, in my opinion and in my experience, the more independent the microservices are, the better, the more benefits you get. And in the code nomenclature, you can think that every microservice should be a separate project or a separate solution that is put in its own repository, so there are no connections between them. Then you can truly experiment with code, and then you can truly deploy them independently. But another thing is the database, again, for the second time. Because splitting the code isn't that hard. But if you neglect the database, if you ignore the fact that it can be the hidden coupling between your microservices, well, then you can be screwed after some time. When you try to upgrade one microservice and you try to upgrade another microservice and they just go this way, because they share a common database and they require to run some scripts that conflict with each other. So we should try to evolve to the state that every microservice has its own database. And databases can be different between the microservices. One can use SQL Server, another can use for RavenDB or another document DB or another relational DB. Every data store should be really considered about what data it will store. And we should choose the database appropriately. And for the second time, database should be also a target of continuous integration and continuous delivery. Because if you need to run scripts manually on your production server just to upgrade the database, well, you're not doing it perfectly, to be honest. So should microservices be 100% independent? The truth is, in the perfect world, yes, they should, because the more independent they are, the more benefits you get. If our microservices consist of many separate processes, these processes need to talk to each other. And inter-process communication that crosses process boundary or crosses machine boundary must be hard, right? Well, let's see what possibilities we have when it comes to communicating processes. The first thing is RPC, remote procedure calls. Remote procedure calls, meaning CORBA or RMI in the ancient history. Now we have, for example, WCF, Windows Communication Foundation from Microsoft. And I don't like WCF. I loved it 10 years ago when I read the specifications. When I read the white papers, it all seemed really nice and really well, until they implemented it. My problem, any of you working with WCF or liking it? Okay, so there are several people. My problem with WCF is that 90% of problems that you get when you are working with WCF is that you can fix them by opening the configuration file and increasing some quota to int.max. And if you had configuration file for WCF that has everywhere int.max written when you expect a numeric value, everything will probably work. But the real problem with the RPC, not only WCF, is that the developer that writes code using RPC isn't always aware that the method that he calls on a given object will result in network communication. So he just takes some object, writes a dot, calls a method, and everything works great on his machine because he has everything set up locally. But if you deploy it to production where you have dozens of machines, possibly, and the network communication becomes really high, the network traffic becomes really high, then you have problems, performance problems, because, well, the developer didn't really knew that a method call will result in a TCP connection. There is another way. We can use HTTP, and I know that WCF can be used via HTTP, but if I was HTTP, I would consider it a violation. So we can use HTTP and REST. You can do RESTful services, which is just plain text, human-readable plain text. We have a lot of lightweight, nice libraries in every technology to configure such service and to execute such communication. In my opinion, when you do REST, you shouldn't really put any abstractions on top of the REST clients, how they are often called, so that the developer is fully aware that when he calls client.put, client.get, client.post, and then some command or some query, that it will be a network communication behind. So then the developer will try to limit such calls, and we will avoid problems in production when everything works on development machine but stops working on production environment. And the problem with REST is that if we have, let's say, 10 services and one of them goes down, then everything goes down. With REST, we need everything to be online all the time. So we lose one of the main benefits of microservices, which is that we can do independent deployments, or that we can take one component down without really affecting all the other subsystems. And there is a solution to that problem. It is queues. When we do message queuing, the whole communication becomes asynchronous. So if we have a front-end application that takes some orders, and then we have some back-end service that processes those orders, the front-end only takes the order, sends message via message queue, and if the back-end system goes down, well, this message will simply wait in the queue until this back-end system goes up again and starts processing these messages. So if we are using communication by queues, then we are resilient to downtime. Because if one system fails, other systems will still work. But there is a problem with queues and with asynchronous communication, and it's called eventual consistency, which says that your data will be stale. Your data will be old. You won't have fresh data all the time in all your data stores. I will get back to this picture because the other one is ugly. And you can try to fight this fact that eventual consistency is present in your system, or you can accept it. And the sooner you accept it, the better, because there is no other way to scale your system without accepting an eventual consistency. And it will affect the way how you communicate with your users, because you can't be 100% sure, your front-end application won't be 100% sure if the order processing succeeded or not. So we must think, what to tell the user? Well, we can tell, we took your order, everything is fine, goodbye. And this is how Amazon works. When you go to Amazon, buy some book, it will tell you that your book is yours, it will be delivered soon, and so on. But the front-end application of Amazon isn't fully aware if this book is really available in stock or not. You have this information if something is out of stock, but it's not updated in real time. And it didn't happen to me, but I heard that if you buy a book on Amazon and it's not available after your purchase, you will get an email with apology and with several dollars as a recompensation for this scenario that this happened to you. We can also think how Twitter works or how Facebook works. If you go to Twitter and you send a tweet, it will immediately show in your timeline, even if it hasn't reached the server. It happened to me 2 times that I sent a tweet, then refreshed the page, and it wasn't there. Because there was some miscommunication between my browser and the server, but the browser, the client-side application, assumes that everything was OK. And it is the only way to deal with scalability, to assume that it will be OK, but if something breaks, then take some countermeasures. And this will need approval from business people, because it will change how you interact with your users. But, well, you can try to explain to the business people that simply there is no other way, and that the great big companies accept this and deal with it. So is the communication hard? Well, this is a myth, but it depends on how we look at this. It can be hard because you need to maintain these queues, you need to monitor them, you need to back up them, and so on. But, well, you need to maintain databases as well. You need to maintain all your applications as well. So these are administration problems, and these administration problems happen all the time. There is nothing special to queues or to the communication. But if you try to implement your system using queues, well, give yourself 30 minutes when you get back home from this conference. In .NET world, install RabbitMQ, install mass transit, read the tutorial or some first page of the documentation, you will have a running system using queues in no time. It really is that simple. If we have one big application, a monolith, monitoring it and seeing how it works and basically fixing it when it breaks is kind of hard. So is it harder when you have 20 applications instead of 1, but 20 smaller applications? Let's see. Well, we all know debugging, but in the microservices world, it is like a unicorn. We need to assume that debugging in microservices simply doesn't exist. When I try to debug application using Visual Studio and I click Attach to Process, it tries to attach to the process so I can debug it. 10 times out of 100, Visual Studio will crash. If I had to connect to 20 different machines, to 20 different systems using the same Visual Studio, I'm sure it will crash 90 times out of 100 instead of 10 times out of 100. So what can we do without debugging? Uncle Bob Martin once asked a great, very important question. Would you rather test first or debug later? If we can't debug later, well, we need to test first. And we really need to take care of our code and take care of its quality by writing automated tests, which, when done well, really work. when we have automated deployments and we have many applications on many different environments and machines, well, we need a place to have all information about the environment, about the services, about the communication between them, about the process boundaries, about the message types that are sent between the services. And several years ago, I wouldn't think that I'd say it, but documentation is really required. But we should not really just open a Word document and put everything in there, because as we know, it will become out of sync the next day. We can use tools for that. When I described Octopus Deploy before, tool for deployments, it will be the root of all of our environment documentation, because it will need information about all the environments, about all the queue addresses, all the IP addresses, all the machine names, all the passwords, all the connection strings, and so on. So it will be our documentation, and we shouldn't duplicate it in Word documents. And another thing, which is logging. When we have our tests, well, we know that they won't guarantee that everything will work 100% of the time. But we don't have debugging, so we need logging so that we can see what actually is going on in our system. The simplest thing we can do is just to log from each application, save text files under logs directory in each machine, in each application directory. But when you have one application, well, I don't know about you, but when I was forced to log in via remote desktop to download 5 GB text file just to see that there is no log that I need there, well, it was very hard experience. So this is not the proper way to do it. And there are two concepts that help with it. One is centralized logging, so that every application should send its logs to the same target, so that we have all the logs in the single data store, so centralized logging. And the second thing is semantic logging. Semantic logging means that logs are not treated as text, as lines of text, because the standard approach is that each log is just a line of text saved to a text file or to some database. Semantic logging tells us that each log is an object. It becomes a line of text when we save it to a text file, but not before. We can use, in .NET, there is a library called Serilog. We have log4net, we have nlog, we have also Serilog, which embraces the concept of semantic logging and integrates really well with a product called Elasticsearch. It takes our logs, puts them all in Elasticsearch, and Elasticsearch is your private Google. You just install it, put gigabytes of text there, it will index it, it will allow you to search it, it will color the results for you, and so on. If you have your private Google with your logs only, life becomes much easier. So microservices are hard to maintain? Yes. But you have simply to be aware of it and think how you can make it easier by logging, by monitoring, by writing tests, and so on, without debugging. And the last but not least, when you start a new project, should you do microservices because it's so popular, or should you do a monolith and split it to microservices later? Well, Martin Fowler says that you should always start with a monolith. And my experience says something different, because once we had a requirement to implement a system that will send SMS messages to some users and email messages to other users. We thought for a while, and it appeared to us that we really know the domain of communication really well, because we've been doing it for years. We know the business really well, because we work for the same company for years. So we thought we will do this as microservices. So instead of doing a single service that will send SMS messages and mail messages at the same time, we divided it to one SMS service and one email service. And it was very beneficial a week later, because the SMS gateway that we used stopped working. It put some gibberish instead of the sender number. And if we had a monolith, a single service, we would have to comment out the code that is sending SMS messages and deploy it again to send only email messages and so on. But what we did when we had microservices, we simply went to Windows Services window and disabled the service that was sending SMS messages until the SMS gateway was fixed. So the most important thing, as always, is to be conscious, is to know how to acknowledge your decision, whether it will be beneficial or not. And very important are the things that I told you earlier, is that your organization, your team, and your skills must be good enough for it to work. So you need to have automation, you need to have testing, you need to have integration, you need to have scripts. Basically, no manual work should be involved in the deployment process, because otherwise you will fail. There is no other way, unless you outsource your deployment process to India, where you will have, 100 of people that will be clicking through your installation checklists. So, yeah, it depends. Again, the really consultant answer, you can't tell upfront without knowing the domain, without knowing the organization, whether they are ready for microservices, because you need to be ready for microservices to do it. And the micro bonuses about microservices is that you need to pay special attention to these two things. Distributed transactions. If your system is using distributed transactions, well, there is a hard way in front of you, because you won't have distributed transactions in microservices world. If you do queuing, you won't have microservices. If you don't use MS, MQ, and SQL Server and .NET, well, you won't have distributed transactions, and you have to deal with it. And the good news is that it is doable. It is hard, but it is doable. You just need to implement a proper strategy to revert operations when something breaks. Every developer must be conscious of this fact. And another thing is versioning and deploying the databases. And it is a quite complex topic. The solution is rather simple, but it is quite complex when you approach it and you try to figure out how to do it. And the figuring out part is hard, because there are really not that many materials online about this problem. But it is doable, and it worked in our company. So database was treated as code, and it was deployed, managed, and versioned in Git repository and deployed automatically. So the concept of microservices is really simple. And it makes the development part easier. It makes the developers' work more fun. But the real problems don't disappear. They are moved from coding to what happens after you do git push. And you need to be aware of that and be prepared to deal with these problems, to embrace the fact that DevOps culture is here. And basically, the most beneficial thing about microservices in our team was that everybody needed to know how everything works. We already had the culture that every developer did database code, did C# code, did JavaScript, did styling, did everything. And in addition, every developer needed to know how TeamCity works, how Octopus deploy works, how to create NuGet packages, so that if any of us, well, maybe not dies, but goes on vacation, someone could take over. And it is a very good thing, because then every day is a new adventure. So you also need to have automation and monitoring, and then you get a chance of success. And note that I don't say guarantee of success, but a chance of success. Without these two things, you have a guarantee of failure. Thank you.